All right, second example for implicit differentiation. We have 1, 2, 3, 4 terms. So we have to go through and take the derivative with respect to x for each term. So your derivative for 4x, ignore everything else, just do the derivative of 4x, is just 4. And we're taking the derivative of x with respect to x. Now, as we move forward, you guys can start skipping this step. If you know dx is in the term, you don't even have to write it because it's going to cancel itself out. All right, so the second term, if we take the derivative of y to the third, we get 3y squared, but we're taking the derivative of y with respect to x, so it's dy dx. Next term, derivative of 12y is just 12, but we took the derivative of y with respect to x, so we have to write dy dx again, equals, and the derivative of any constant is 0. All right, so this time we have 2 terms involving dy dx. I don't care if you have 2 or 12 terms involving dy dx. Get them all together on one side and get everything else on the other. All right, so I'm going to cross out the dx here, and at the same time, I'm going to move the 4 over. So we end up with negative 3y squared, dy dx, plus 12 dy dx equals negative 4. So you want all the terms containing dy dx together on one side and everything else on the other, even if the other terms have x's and y's in them, get them all on the other side. The reason you want only the terms containing dy dx on one side is because you can now factor it out. So if I factor out dy dx, I am left with negative 3y squared plus 12, and that equals negative 4. And in order to get dy dx by itself, we just divide both sides by negative 3y squared plus 12. So dy dx, our derivative, is negative 4 over negative 3y squared plus 12. You can clean this up a little bit. If you were to factor out a negative 1 from the numerator and denominator, you would end up with 4 over 3y squared minus 12. You have to change the sign of every single term. You could go one step further and factor the 3 out from the denominator and then factor the difference of 2 perfect squares. I'm not going to ask you to do that, but you could go further if you wanted to. I don't know if Miss G is going to ask you to go further next year. I'm not really sure, but this answer is where I want to stop.